For this video, we're going to be covering first normal form. And you should know there are actually 6 rules of normal form that apply to relational databases. And for this course, we're just going to go through the basics. Right now, we're just going to start with the first normal form. But the point of normal form, it's the rules of normalization. And I said normalization is just a nice fancy word for optimization. How do we structure the database correctly for a lot of reasons? And to get formal here, the reason why we normalize the database is so that the data is consistent. We don't want any quirks that kind of back us into a corner. So when we try to expand the system, we have to restructure the system to meet the new requirements. We want the queries to be easy to make. If you have stuff like example being first name, last name, username, password, those really for the most part usually go in the same table. It wouldn't really make sense to have username, oh better yet, first name in one table and then have to do a join to another table to get last name. They really should go together. And there'll be other cases where the data does need to go together. Next one is good performance. We're always very impatient. We do want our database to work well. Right now we're one person querying one database. But ideally, you may have a database sitting on a mobile phone where still you're one person querying a database, but it's on a much less powerful device. Or you may put it on a large server where it might be hundreds or thousands of people querying the same database. And we need to keep performance up with that. We also need to eliminate duplicate data. That can lead to inconsistency. Like we talked about with genre, we would make that more of a drop-down. Let's go to genre over here, where we would let people select action, adventure, horror, family, whatever genres you have, as opposed to just letting them type it in, because then we'd end up with some being action, some being adventure, some being adventure spelt wrong. Anyway, you'd end up with a whole bunch of different ones that really should be in the same grouping. So we want to eliminate repeating groups of data, not only for that, but it lends to consistency and speed and other stuff, as well as also being forward compatible. One of the things to think about is you have a nice shiny laptop in front of you. That's something that is good for now, but in 10 years, I assure you it's going to be an antique and a paperweight. So it does need to be able to be portable and move from one system to another. So there's lots of reasons. That's actually another reason for a database, but there's lots of reasons we normalize databases. We want it to be able to grow. So here is the technical definition of first normal form. And what that says is that it eliminates repeating groups of individual tables. Basically stuff like that genre and station where it repeats over and over again. You want to do the second thing here, which is create a separate table for those each set of related data. You want to separate those repeating groups off. So stuff like we did over here, where we took cable raw data, and we went through and said, well, which ones are repeating? Again, I like to say which ones on a form would be a drop-down value as opposed to something I would free text and type in. And obviously station and genre are the ones that have repeating values. They're the ones that do need to be selected from a drop-down, so they all are uniform and the same. And those need to be separated off to other tables. So we created the genre table, and these lookup tables should always have an ID column and a name column. And I don't care what their labels are, but what it comes down to is we have an integer field and a varchar, if we're using integers as the primary key. And the reason is we can then go ahead and just populate those, have those unique IDs assigned. And then as we went later on, went to the listing table and said, okay, if I want to look up, I believe Agents of S.H.I.E.L.D. is on ABC, I would put a 1 in there, and that 1 would link over to, let's go to station here, ABC. Same thing for the station table. Next one, identify each set of related data with a primary key. Basically, every table should have a primary key. If we go through the structure of every table here, stations, primary key, ID, primary key, item ID, every table needs to have a primary key. And we discussed that it could be a single column as an integer or maybe even a varchar. The users here has their user ID as a string, a varchar. Or it could be something like order item, where that primary key is a multi-primary key. You need to look down here to see both of these columns compose the primary key. So the combination of those two must be unique. And then the other one is every field, meaning every column, has exactly one value. Do not use comma delimited list. Basically what it means is you have a, best example here, we have an order ID and an item. And we know when we join tables together, we were able to join it to the order table and the item table, and we had a quantity of how much this person or this was placed on this order. The one thing we wouldn't do is like go into the orders table and create a varchar, and then in there put, I put item ID 1, comma, item ID 5, comma, item ID 6. And the reason is the database has really no ability to parse data inside of varchar and then perform a join. It needs to actually be in a field on its own. So stuff like this, we would go ahead and just create one field, one column here per value. Don't stuff several values in a single column. Now, I'm not saying you shouldn't have a field where someone may put a paragraph. Well, all that data does go together. But for something like this, where we're going to join on, where we're joining item ID and order ID together, you can't stuff multiple item IDs into one field or multiple order IDs into one field. Let them be separate. Here is actually an example of how we want to structure our table versus how we do not want to structure our table. And I'll start off with the not, what we don't want to do. I created a table called invoice, and that is in our database. And the one thing you'll notice is I put an invoice ID, a first name, a last name. That's fine. It connects to someone. And then I have item ID 1, item ID 2, and item ID 3. I'll assume that these three item IDs can point at this item ID in the item table. But the reason why I wouldn't do this is what happens if someone places an order and only orders one item? Well, now I have two fields here that are a waste of space. They exist, they take up room, we've declared them, but they're nulls. There's no data in them. So it's just going to take up blank space on your hard drive, on your system, and it's kind of inefficient. The other thing to think about is now what happens if I don't place one item on this order? What happens if I go ahead and try to place 5 items? Well, we only have item 1, 2, and 3. So I have to create a separate entry in this table for item ID 4 and 5 and put it at 1 and 2. So all of a sudden now I got to create another invoice because I ordered too many items. And what happens if I'm a shopping addict and I go in, or I'm ordering for a company and I order 200 items? Do I have to go ahead now and have how many invoices? 3 divided by 200? It would be frustrating for the user. It would be very inefficient. However, something like this setup where we have an orders table that only has the identifying marks for the order, meaning it connects to a user, we have a date, the entire order shipped, was placed, and a date when we're going to ship it. And then I have a separate table here that says, well, for that order, I can place 1 item onto that order. I can place 200 items to that order. I can place 1,000 items. And I can store the quantity for each one with it. I guess we could put quantity in here. Maybe we'll have item ID 1 quantity, item ID 2 quantity. But the point is we're still going to be wasting more and more space now because I don't know what's the limit. Are we going to limit people to ordering only 10 items? No, what we want to do is separate it off to this middle table here where we can add 1 item and no space is wasted. And then I can add 1,000, 100,000, however many items you want to order. This model, these 3 tables below, are flexible enough to go ahead and place as many items as you want. So that is basically the summary of first normal form.